So we want to solve a system of equations here using the Gauss-Jordan method. We're going to proceed by elimination to find the values of x, y, and z. Of course, by creating triangles of zeros on either side of a diagonal having 1, 1, and 1. The first thing we want to do here is to create a matrix out of this system using the coefficients in different rows. For row 1, we will have 2, minus 1, 0, and 2. Row 2, we will have 1, 2, minus 2, and 4. And for row 3, we will have 0, minus 1, 1, and 1. The thing here is to get to a matrix in this form where x, y, and z could be easily identified. So now that we have a matrix with the rows 1, 2, and 3, we want to take 2 in row 1 as pivots and proceed to have 0 under it. And with already 0 at row 3, it makes it more easier. That said, to get a 0 at row 2, column 1, we want to take 2 row 2 and subtract it from R1. Of course, maintaining R1 and R3 intact. It gives us 0, 5, minus 4, and 6. Now we consider 5 to be our pivot and proceed of getting 0 under it. To do that, we want to take 5R3 and add it to R2. It gives us the new row 3, 0, 0, 1, 11. And again, row 1 and row 2 are not changing. From here on, we have the value of z, 11. We can just replace it upward to have y and x. But still, we're going to continue eliminating till we get to the form we said before. And now we want to divide row 1 by 2 and row 2 by 5 so that we could have 1, 1, and 1 diagonally. So now we're going to have our matrix with at row 1, 1 minus 1 half, 0, and 1. And at row 2, 0, 1 minus 4 fifths, and 6 fifths. So we said our row 3 remains the same and row 3 remains just the same. We can see how our triangle is formed here and the value of z is still 11. And we're going to continue reducing or eliminating till we get to the form of the matrix I showed you from the very beginning. So let's move forwards here. We are taking 4/5 of R3 and add it to R2, which gives us the new row 2, 0, 1, and 0 equals to 10. And to complete this elimination, we will divide R2 by 2 and add it to R1. What is going to give us the new R1, which is 1, 0, 0, and 6 as a result. Now we are done here with the elimination, and we can see 2 triangles at both sides of the diagonal 1, 1, 1. And that is what we wanted to do. And now it is obvious. It's very easy to find out the solution to this system of equations. We have at the first position x equals to 6. And then we're going to have y equals to 10. And z equals to 11. And now to recap everything, we had a system of equation with the x, y, and z that we have to determine. We used the Gauss-Jordan method to proceed by elimination to find the unknown values. We got to the result where x equals to 6, y equals to 10 and z equals to 11.